requirement for ground fault circuit interrupter protection over showers and tubs and Underwriters Laboratories listed bath fan still applies regardless of the location of the fan, as long as it is in the same bathroom where the shower or tub is located. This is because the Underwriters Laboratories listing is based on the intended use of the product. In this case, the fan is intended to be used in a bathroom with a shower or tub. The ground fault circuit interrupter protection is considered an essential safety feature for this application, as it helps to prevent electrical shock in the event of a ground fault. Therefore, even if the fan is mounted above and outside of the 3-foot by 8-foot code required area, it must still be connected to a ground fault circuit interrupter circuit in order to comply with the Underwriters Laboratories listing. The Underwriters Laboratories listing is a safety certification provided by Underwriters Laboratories, a globally recognized safety organization. It indicates that a product has been tested and meets specific safety standards. In the context of bath fans, the Underwriters Laboratories listing ensures that the fan has been evaluated for electrical safety, fire resistance, and other potential hazards. Ground fault circuit interrupter protection is a safety measure designed to protect individuals from electrical shock. A ground fault circuit interrupter constantly monitors the current flowing through a circuit. If it detects a difference between the outgoing and returning current, even as small as 5 milliamps, it quickly interrupts the circuit, cutting off the power. This interruption happens in a fraction of a second, fast enough to prevent serious injury or death. Ground fault circuit interrupters are particularly important in wet locations like bathrooms because water can significantly increase the risk of electrical shock. A ground fault can occur when electricity flows through an unintended path to the ground, such as through a person's body. The 3-foot by 8-foot area mentioned refers to as and around a bathtub or shower that is considered to be a high-risk area for electrical shock. Electrical codes often specify stricter requirements for electrical installations within this zone, including the use of ground fault circuit interrupter protection. However, the Underwriters Laboratories listing requirement for bath fans extends beyond this specific zone. The requirement applies to any bath fan installed in a bathroom containing a shower or tub, regardless of its proximity to the water source. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations in buildings. It outlines the requirements for wiring, overcurrent protection, grounding, and other safety measures. While the Underwriters Laboratories listing and the National Electrical Code are distinct, they are often related. The National Electrical Code may reference Underwriters Laboratories standards and require the use of Underwriters Laboratories listed products in certain applications. The intent of requiring ground fault circuit interrupter protection for bath fans in bathrooms with showers or tubs is to provide an additional layer of safety. Even if the fan is located outside the immediate vicinity of the water source, there is still a potential risk of electrical shock, especially if the fan is not properly installed or maintained. The ground fault circuit interrupter protection minimizes this risk by quickly interrupting the circuit in the event of a ground fault. When installing a bath fan in a bathroom with a shower or tub, it is crucial to ensure that it is connected to a ground fault circuit interrupter protected circuit. This can be accomplished by using a ground fault circuit interrupter circuit breaker in the electrical panel or by installing a ground fault circuit interrupter receptacle. It is also important to follow the manufacturer's instructions for installation and wiring to ensure that the fan is properly grounded and protected. Ignoring the Underwriters Laboratories listing requirement for ground fault circuit interrupter protection can have serious consequences. It can increase the risk of electrical shock, potentially leading to injury or death. It can also violate electrical codes and regulations, resulting in fines or other penalties. In summary, the Underwriters Laboratories listing requirement for ground fault circuit interrupter protection over showers and tubs in Underwriters Laboratories listed bath fans is a critical safety measure that applies regardless of the fan's location within the bathroom. It is essential to comply with this requirement to protect individuals from electrical shock and to ensure the safe operation of the bath fan. It is always recommended to consult with a qualified electrician to ensure that electrical work is performed safely and in accordance with all applicable codes and regulations. To further clarify some technical aspects of ground fault circuit interrupters, let's delve into their operational principles and installation considerations. A ground fault circuit interrupter works by monitoring the balance of current between the hot and neutral conductors in a circuit. In a properly functioning circuit, the current flowing through the hot conductor should be equal to the current returning through the neutral conductor. However, if a ground fault occurs, some of the current will flow through an unintended path to ground, creating an imbalance between the hot and neutral conductors. The ground fault circuit interrupter detects this imbalance and quickly trips the circuit, cutting off the power. The sensitivity of a ground fault circuit interrupter is typically set to 5 mA. This means that it will trip the circuit if it detects a current imbalance of 5 mA or more. This level of sensitivity is sufficient to protect individuals from electrical shock, as even a small amount of current can be dangerous. Ground fault circuit interrupters are available in several different forms, including circuit breakers, receptacles, and portable units. Ground fault circuit interrupter circuit breakers are installed in the electrical panel and provide protection for an entire circuit. Ground fault circuit interrupter receptacles are installed in place of standard receptacles and provide protection for devices plugged into that receptacle. Portable ground fault circuit interrupters are designed to be plugged into a standard receptacle and provide protection for tools and equipment used in temporary locations. When installing ground fault circuit interrupters, it is important to follow the manufacturer's instructions carefully. Incorrect installation can render the ground fault circuit interrupter ineffective and increase the risk of electrical shock. It is also important to test ground fault circuit interrupters regularly to ensure that they are functioning properly. Most ground fault circuit interrupters have a test button that can be used to simulate a ground fault and verify that the device is tripping correctly. The National Electrical Code provides detailed requirements for the installation of ground fault circuit interrupters in various locations. For example, the National Electrical Code requires ground fault circuit interrupter protection for receptacles installed in bathrooms, kitchens, and other wet locations. The National Electrical Code also specifies the types of ground fault circuit interrupters that are permitted to be used in different applications. It is important to consult the National Electrical Code and local electrical codes to ensure that ground fault circuit interrupters are installed correctly and in accordance with all applicable regulations. In addition to ground fault circuit interrupters, there are other types of safety devices that can be used to protect against electrical shock. These include arc fault circuit interrupters and ground fault equipment protection devices. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults. An arcing fault occurs when electricity jumps between two conductors, creating a spark or arc. Arc fault circuit interrupters detect the characteristics of arcing faults and trip the circuit, preventing the arc from igniting nearby materials. Ground fault equipment protection devices are designed to protect equipment from damage caused by ground faults. These devices typically have a higher trip threshold than ground fault circuit interrupters, typically around 30 mA. They are intended to prevent equipment damage rather than to protect individuals from electrical shock. When selecting safety devices for electrical installations, it is important to consider the specific hazards that are present and to choose devices that are appropriate for the application. It is also important to ensure that all safety devices are installed and maintained in accordance with the manufacturer's instructions and all applicable codes and regulations. Furthermore, it is important to understand the difference between a ground fault and a short circuit. A ground fault occurs when electricity flows through an unintended path to ground, while a short circuit occurs when electricity flows directly from the hot conductor to the neutral conductor or ground conductor. Both ground faults and short circuits can be dangerous, but they require different types of protection. Ground fault circuit interrupters are designed to protect against ground faults, while circuit breakers and fuses are designed to protect against short circuits and overloads. Circuit breakers and fuses interrupt the flow of electricity when the current exceeds a certain level, preventing damage to wiring and equipment. Overloads occur when too much current is flowing through a circuit, typically due to too many devices being connected to the circuit. In addition to safety devices, proper grounding is also essential for electrical safety. Grounding provides a low-impedance path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and clear the fault. Grounding also helps to reduce the risk of electrical shock by providing a reference point for voltage. All electrical equipment and wiring should be properly grounded in accordance with the National Electrical Code and local electrical codes. The grounding system should be inspected regularly to ensure that it is intact and functioning properly. Another important aspect of electrical safety is proper wiring techniques. All electrical wiring should be installed in accordance with the National Electrical Code and local electrical codes. Wiring should be properly sized for the load that it will carry, and connections should be made securely. Damaged or deteriorated wiring should be replaced immediately. It is also important to avoid overloading circuits. Overloading a circuit can cause the wiring to overheat, increasing the risk of fire. To avoid overloading circuits, it is important to know the ampacity of the circuit and to avoid connecting too many devices to the circuit. The ampacity of a circuit is the maximum amount of current that the circuit can safely carry. The ampacity of a circuit is determined by the size of the wiring and the type of insulation. The National Electrical Code provides tables that list the ampacity of different types of wiring. In conclusion, electrical safety is a critical concern that should be taken seriously. By understanding the principles of electrical safety and following all applicable codes and regulations, it is possible to minimize the risk of electrical shock, fire, and other hazards. It is always recommended to consult with a qualified electrician to ensure that electrical work is performed safely and in accordance with all applicable codes and regulations. Remember to test ground fault circuit interrupters monthly per manufacturer's instructions. This small step can ensure that the safety device is functioning properly and ready to protect you in the event of a ground fault.